Hello friends, let's learn about binary search algorithm today, and we'll also try to implement it using Java programs. So a binary search is also known as half interval search. It is a search algorithm that finds the position of target value within a sorted array. This is very important. You can apply it within a sorted array only. Binary search compares the target value to the middle element of the array. If they are not equal, the half in which the target cannot lie is eliminated and the search continues to the remaining half. Again, taking the middle element to compare the target value and repeating this until the target value is found. If the search ends with the remaining half being empty, the target is not in the array. So here, with every iteration, it breaks the list into half. Let's try to understand it with the help of an example. And its average value is O log n and best case performance is O1. Okay. Now here this is a sorted array and suppose we need to find 23. So first of all, as it per the process, we need to find the middle element. So 16 is the middle element. Now we'll compare the value of middle element with the value that I want to search. So 23 is greater than 16. So I will search in the right side and left part of the array is ignored. So the list becomes half. Now again we'll find the middle and we'll see that whether the search value is greater than or less than the middle value. So 23 is less than. So again right side of the array will be ignored. And in the third iteration I can find my value. Let's see another example. So in this sorted array, if I want to find 75, so in that case, first of all, I'll find the middle element. And so 75 is greater than the middle element. So I'll move right, left side of the array will be ignored. Again, from the remaining array, I will find the middle element and we'll see whether the search value is at the left side or the right. Again, 65 is less than 75, so I'll move right and the remaining part of the array is ignored. And in the third iteration, I will be able to get the value. So this is how the binary search algorithm works. Now, let's try to do this using a Java. Okay, in the Java programs, let's try to. Okay, so this is the Java program that I had. So this is the class. This is the main class that I had added. Now, let's try to search, do a sorting on this array. Okay, so what I'll do, I'll first create a method that will do the binary search. So I'll do public static boolean binary search, and we will use the recursive strategy. Okay, and here I'll this method will accept an integer array, then it will take search element, and then it will take one left and right part. Okay, now first of all we need to find the middle element. Okay, so I'll find mid equal to left plus right minus left divided by 2. This I'm doing just to avoid any overflow condition. And here if left is greater than right, then I will return false, means it didn't found. So first of all I need to find if the middle element is the value that I am looking for, the search element. So I'll add if condition if here mid is equal to search element. If If yes, then I'll return true. Else, I'll find, as we know, whether the value that I'm looking for, I need to iterate the left side part of the array or the right part. So else if ARR mid is greater than search element. If yes, then I need to, the right hand part will be right equal to mid minus 1, else left equal to mid plus 1. Why I'm doing this mid minus 1? So suppose the value that I'm looking for, I need to go to the left part. So starting will be this, and the end will be third index. And in case if I need to go to right, then starting index will become after the mid index. So that's why it is plus 1 left will be, okay. And if it is not finding, then I'll return false, okay. Now since it's a recursive search, I'm using recursive algorithm. I'm implementing it in recursive way, so I need to call this method again. So here the input value will be ARR, then search element, and then left, and then right, and same will be here. And to call it, let me try to call boolean found equal to binary search. It will take sorted array. Then the element that I want, suppose I want to search 7, and then the left will be 0 starting index, and right will be the end index will be sorted array dot length minus 1. Why minus 1? Because I don't want to go array index out of bounds error, okay. So boolean, and then I'll just do a sysout system.out.println search value found plus, so I'll just add a question mark, so this will return whether the search value is found or not, okay. So this is done using recursive strategy. Let's try to run this and see if 7 is found in this or not. Let me try to run it. And here I can see the system index, there's an error, binary search. Okay, let's try to here there is some syntax error, so I remove the syntax error. Okay, so the value found is true now, which is correct because 7 is found. Now let's try to find something which is not there in the list, which is 77. And if I'll run it now, it should return false because 77 is not present in this list. So it is returning false. Okay. So today we learned how to do a binary search using recursive strategy. We can do the same thing in an iterative strategy as well. If you want to do this, you just need to do binary search, and using the while loop as well, for and while loop. So let's try to do it using binary search in another way. So here I'll write left equal to 0 and int right equal to uh, search element dot length -1. So I'll not pass the starting and end index. Okay. And instead of if, I'll write while. I'll just remove here and return this. And instead of this, I'll because I don't want to call it recursively. So while left is greater than right, I'll try to see. And this logic remains same. So instead of calling it recursively, I am doing like this. Okay. Let's try to see if it works. Search int cannot be differenced. Okay. Here I need this value actually. Okay. So we can see that it's returning true the elements. So we have learned how to do binary search in an iterative way as well as in a recursive way. Thank you viewers for watching. Do like and subscribe the videos. And if you want us to implement any new algorithm, do write to us in comment box. Thank you so much.